Good afternoon. Last day. Yeah. So, today we are going to really combine a lot of different things that we learned this quarter into one class that we call a matrix class. We're going to template that matrix class. We're going to overload operators for that matrix class. We'll see how far we get today. But the point is to kind of show that you can write readable, decipherable, powerful, generic code that enables equally general, easy to program libraries that you can use, or syntax that you can use in order to solve other interesting problems. Okay? So I want to start out first by making the following observation. This is what I awoke to this morning. See this? That's not you. That's my other class. Right now they're my favorite. Okay? Look at that, 25 out of 28. Well, look at your class. All right, so there's bound to be at least one person in this room that hasn't done it yet. So there you go. All right, so I'll check back on this later this afternoon, and if that's above 40, then I'm going to start getting to work, and I'll post it as soon as I can, within reason. Okay, but that was a beautiful thing I awoke to, because what it meant is I don't have to do anything right now, but it's so close within reach. Okay. I don't think you'll beat the 89.3% of the other class, but you can try. You can try. Okay. So let's remember last time we created this matrix class. And I mean, just look at this code right here. We look at this code right here and we say, well, this is kind of like C-style code in a sense. We have a bunch of for loops, and we print out the matrix. But really, that fact that we could write matrix of 3, 5 is actually kind of cool. Okay? Now, from what we know about templates, we didn't create a matrix class. What did we do? We created a template for which the compiler can generate classes with various parameters plugged in. Okay, so when I write matrix 3, 5, and then I write matrix 4, 7, the compiler is going to generate 2 completely separate classes. So we know this. Okay? Now, let's C++ 11ify some of this stuff here. So I think this will work. So here we go. For auto x in. Will this work? No, I don't think this is going to work. I have to enable that syntax. OK. So for now, we're stuck with this. OK. Now, what operations did you guys have to have defined in order to be able to use the auto x colon? Was anyone able to implement the range-based for loops for their homework? Get it to work? OK. So we just need like a begin and end, things like that. So let's try and enable that right away. So we go to matrix, and here's our matrix. Remember, we're using an array of arrays, and these are fixed size stack memory arrays. Okay? And we also template the underlying data type, which is double, and we can change that to easily. So this is where the key part of generic programming comes in, is I can easily change that to an int. And I get a warning about converting from I times j times 1.23. It's going to round down. Well, not round down, but it's going to truncate. And I get an integer valued matrix instead. Okay? But it's as easy as changing this to something else. Okay? So I could even do maybe .2d. Can I do a .2d? Nah, I can't do that. Why can't I do a .2d? Well, yeah, did I include the library? No, I didn't. OK, that's for step 1. Okay, so let's include that. Now, points is also templated, so I can't just do a point 2D object. I have to do something like point 2D of maybe doubles. Whoa, but now look at this. There's only one error. The only error is that you can't assign a point 2D object in this manner. What does a point 2D object need? It needs 2 arguments, right? So maybe let's write the following. Point 2D of this, point 2D of double. And let's do this, comma, I don't know, I minus j minus 12. Whoa, see that? It just compiled. Check that out. That was interesting. That was not what I was expecting. I got the x value right, but did it get the... Oh, that's why I did it, because it was all integer type. OK, this will work now. See? No, what? Oh, wait. OK. All right, I got to write double in front of here. What it's doing is it's doing the arithmetic of I minus j first, and that's size t, which is an unsigned type. And then for an unsigned type, if the arithmetic goes negative, it just cycles around to the largest number. You don't need to know this, but I wouldn't demand you understand that at that level of specificity. I would instead give you the code that actually does what you would expect it to do at least initially. Okay, so this works now, and I'll just again, it's because what it's doing is it's doing before I put the double here, it's doing a size ti minus a size tj, and then that arithmetic is negative, but because it's an unsigned int type, when an unsigned int tries to go negative, it can't store negative numbers, so it actually just cycles around to the largest possible number and goes back. It's like modular arithmetic, if you've heard of modular arithmetic. Okay? So that's what's happening. It's cycling around to the very large number, and then I'm subtracting the 12 from it. Okay? So this converting everything to double means that, oh, when it turns negative, the double can store the negative. Okay? So it applies the right operator minus function to maintain the floating point nature of it. Okay, but that's not the point. The point is now, I've got this. Now, did I define plus for operator plus for points? I didn't. Let's go back to just doubles. Okay, so let's do matrix force 3, 5. And let's just not put anything, okay? And then instead of this line here, we'll put back the initial one, which is just the I times j. Okay, here's the reason why here's what I wanted to emphasize in this lecture here. I wanted to emphasize the following, which is if I have 2 objects of this matrix type, and I try to do something like mat plus mat 2, now if it's just an object of type matrix, and I define operator plus, then no matter what the sizes are of the matrices, the operation plus is a valid function to link for these 2 objects. But because they're templated, I can define an operator plus that only applies to matrices of the same size or the same template parameters. And here's how I'll do it. So we go to our matrix class. And what I'm going to do is I'm going to say, OK, I'm going to make an operator plus equals. Now, what data type should I accept? I should accept a data type of const matrix mnt reference. Call it m. And what is it going to return? It's going to return a reference to an mnt matrix. OK? So again, inside of this function, the parameters m, n, and t. If I had another t in front of all those, that would be kind of... OK. Inside the class, T, M, N, and T are all known. Now when I go to define this function, what I'm going to do is I have to write, this is a member function, so this is a member function of not just any class, not just the matrix class, but the matrix of class MNT. That's the class it's a part of. Not only that, because I went outside of the class definition, I have to tell it that this is a template of size tm, size tn, and then type name t equals double. Oop, and I can't do the default. Okay, remember when I told you in C++ 11 or in Visual Studio 2012, you can have default template parameters on classes, but not on functions. You can have default parameters on Xcode. If you're running Xcode right now, go ahead, try it. You can put t equals double. That's fine. But here you can't. You have to have it completely specified. Okay, which is fine because the matrix object which is invoking this operator is going to know what the operator is. So here, in order, what we need to do is we just do a for size t I equals 0, I less than m, I plus plus. Well, let me just go to the main code I wrote in main. Matrix.h. Okay, so we place 3 here with a m, a capital M, 5 with a capital N, excuse me, and then instead of mat, we're going to do, let's see. So we're going to do this at I and j plus equals m at I and j. Okay. And I need a return. I know I need to get rid of this cout statement. And then I'm going to return. What am I going to return? Star this. And it's the same as it was before, right? The general template for operating overloading operator plus equals is you return a reference to the object, you pass in a const object reference. The first part is you do the actual addition, and you always, always, always return what? Star this. All I'm doing is defining for this particular class what is the particular way in which you add two objects of this type together. Then what's the other function I write? Well, I write a function called operator plus. This is a non-member function. The first parameter is passed in by value. Yeah, very good, very good. Yeah, by value, right? First object is always by value, mt. We'll call this left-hand side. And the second argument is always passed in by const type reference. The templates don't change anything. All the templates do is obfuscate what is happening. But if you just keep interpreting matrix MNT as the class name, then everything is exactly the same. We are, in fact, following a template for how you would define operators. Okay, so we're just doing what we would normally do otherwise, but instead of writing, fraction LHS and const fraction ref, just the name of the type is a little more complicated. All right, so what is the return type here? It is a matrix of M and T. And again, this function is a non-member function. It's outside of any class definition, so we need to, again, tell it that this is a templated function. And now, this is the beauty. What is the code for this function? Yeah, return LHS plus equals right-hand side. That's it. Forget about that for a second. There is no thinking here. There is no difference between the way this operator plus is defined and any other operator plus that you're going to overload. Okay? It follows the exact same pattern as long as you follow this procedure. You only need to memorize basically one or two things. Okay? And you don't have to keep reinventing the wheel or worrying about your style choices. Okay? Now, why did this not compile? Well, I tried to add two matrices of two different sizes. What if I made a matrix of type 3, 5 and call that one mat2 and call the other one mat3? Okay. Now let's initialize mat2 to be something. Let's say mat2 gets maybe I plus j times 13 or whatever. Okay. Now let's compile this. Ah, yes. Oh. Okay. Read the error. This is important. Some of you already encountered this in your homeworks. What does this code say? Error. Binary, open, close bracket, no operator found. Wait, no operator found. I totally defined operator. I have it. The operator's right there. It's in my matrix class. It's fine. What's the problem? See? It's right here, and the error is saying I can't do that. Why can I not do this? Very subtle, but const. Okay. If I try and call a member variable that's not declared const, what might happen? The object might change. If I pass in a const object reference, am I allowed to make any changes? No, and the compiler knows that, and the compiler says, no, you cannot call this function because it is not declared const. So what is the simplest, most elegant solution? Well, the best, probably the better solution among a couple that you might have come up with. Somebody just give me a solution. Sorry. What's one solution? Declare the member function const. That's the better one. What's another thing you could possibly do? Yeah, don't make the argument const, right? So I could go here and I could lazily say, I could be like, oh, I don't want to bother. I don't want to think about this. Why won't this just go away? What if I just change this to that and I get rid of const here and here? And then there's this, and I don't know how, this is stupid. Programming is horrible. I don't know why anybody codes in this stupid language anyway. Or you could just write const here. Oh, wait. Why does anyone code in this stupid language anyway? Oh, is it not const? Oh, I think I need a const here. No, I don't think I want a const there. Do I want a const there? I don't think so. No, because then you can't assign it. Yeah, you can't access it. Wait a minute. What? Okay, there's something I'm not doing quite right here. Cannot convert from a const. Oh, maybe they didn't fix this. Okay. Maybe I do have to get rid of const everywhere. Okay. Well, I can leave const in the member function. That should be fine. But it doesn't like... No, it doesn't like that either. And then I have to change that to... Okay. Looks like if I want to use the array... Do I have the doc for this? Let's see. No, and I don't have... So if you look at val array, this is not array, but for val array, if you look at the operators... this operator, I don't think I have internet here, which is why. Can I click this? Please work. Okay, well, I got it to work right now. Well, I'll check on the constants later. Okay, so I was able to do this. And now if I want to print this out, let's call mat4 of I and j. So we do matrix of 3, 5. Mat4 equals that. Now when I go to print this out, I can print it out right there. Okay, so the first one is mat, and then the second one is the addition of both of those. No, it doesn't look like the addition of both of those. Oh. Wait a minute. Operator plus equals. No, that should have worked. Wait, let me try. Oh, maybe I didn't. Mat2 is that, and I. Oh, that'll do it. Yeah, good call. Yeah, I'm about to fix this in a minute. There we go. Thank you, thank you. Okay. Now, what's the next thing I should probably overload instead of copying and pasting these double for loop each time? The operator, either the print function, that's a good one as well, but in terms of an operator, it's the operator less than, because then what I can do is I can interface that with my file system, and then I can read and write matrices. I can write matrices right away into a file just by having that operator overloaded. So let's go here, and let's make a, and like I said, I think I fixed the whole declare and define a friend thing. So we always make ostream reference operator less than a friend. And we pass an ostream reference out, and then a matrix of, you don't actually, so you can actually just write matrix, matrix reference. Now, you don't actually have to write out the full template parameters each time. You can, but you don't have to. So it knows that it's the matrix of type MNT. But then what I do have to write here is I have to write inline. Now I can define it down below. Okay? We can get rid of friend. But here, now I have to include the template parameters because it has no idea what matrix is. Matrix is not a class that it knows anything about. Okay. That should work. Okay, great. And then I go to my this one right here. Well, let me just go back to main source. When I do the print, okay, if I go back to matrix.h, now, okay, here's my code. I replace this with an M. I replace this with an N. I replace this with mat. And now I have imposed a output style, which is fine. I'm free to do that. And then here I just want to return out. I got to change all my couts to outs. And okay, instead of end-L, this is a subtlety. I'm always going to err on the side of doing a /n. And the reason is because when I do my file output, remember, the way I have my file output set up, I can't handle end-L. I can handle /n, but not end-L. There's a good reason why, but I don't have time to explain it now. So if you're using this only with cout, you can use end-L just fine. It's not a big deal. But if you want to interface it with a file system library, that's when there's a difference between /n and end-L. End-L is a function, actually, whereas /n is just a string that gets appended and interpreted by when it parses the characters. So /n is a more, there's subtle things that happen when you call end-L, like it flushes to the file, it forces a write to the file, but that's a little more complicated. So now this is the beauty. Now watch this. Watch this. See all this complicated code that no one would really want to worry about? Well, let's just replace this with a cout mat. Here we can do endl because it's cout. Okay? Here we've defined mat2 and mat4, and rather than printing it out, we just do a cout on mat4. It doesn't like... Oh, hang on. Where is it? All right, looks like it didn't. Okay, well, there's one easy fix. Like I said before, I'm not 100% sure why it does this. If you define it inline and you actually define it inside the class, like this, it all goes away. Okay? So just for now, for this class, just always define friend functions of templated classes in the class definition. That's a perfectly acceptable style. Okay? Again, I haven't worked out all the details. And you should include comments, of course. But now it works. Now it runs, and it does exactly what you would want. When you want to see out the matrix, you see out the matrix. Now, what's important here is the following. I can add matrices of type mat and mat2. But if I try and add, for example, mat2 plus mat3, it actually will not, the compiler will tell me I'm not allowed to do that. It's not like I run an algorithm and then it tries to access some contents in memory it's not supposed to, or you do a check during runtime to see if the dimensions mismatch. No, this is the compiler taking advantage of the strongly typed nature of C++, and the compiler tells you this is logically illegal. You are logically not allowed to add an object of type matrix 3, 5 double and an object of type matrix 4, 7 double. Okay? That's what's really cool. Now, there's another property which might seem a little annoying, which is the following. What if I wanted to make another matrix 3, 5, but I wanted it to be with ints? Call it mat5. We know this one doesn't work because, dimension mismatch. But now, if we try to do mat plus mat5, even though we can absolutely add together objects of type int, variables of type int and variables of type double, the same cannot be said of the class, an object of type matrix 3, 5 double and an object of type 3, 5 int. Okay? Let's enable it to do so. How would we enable this plus to take place? Watch this. So the idea here is that we want to be able to add, as long as the matrices have the same size, and as long as you can add types of these two together in a plus equals fashion, then we'd like to be able to do something with that. We'd like to be able for that to be legal in this case. So let's do a little trick, which is, well, not a trick, but let's just keep overloading stuff. Well, here's a little subtlety. Is there any reason why this t has to match this t? No. There's no reason. Is there any reason why in this plus equals this t here has to match the return type t? No. So let's do the following. So let's start with this right here. Now, plus equals, again, have in your head t is a double and maybe f, call it f, is an int. So we're going to return, we're going to call plus equals on the matrix of, say, 3, 5 double, and we're going to want to add to it an object of type 3, 5, say, int. Okay? We put in an f. Now, the class has no idea what f is. So we have to write template type name F locally to tell the class, all right, you know what M, N, and T are from up here, but you may not, but we need to know that what we're inputting is a matrix of the same size, but of a different type. Okay? So this is where it gets a little confusing. Okay? So we already have this, and we want this. But now we have to tell it what type name F is. Okay? That works. Now we're going to go down below here, and we're going to change this one from a T to an F. So it's going to adopt or return the left-hand side's type. But now this says, okay, I knew this was going to happen. Okay, what I actually have to do is the following. Okay. Watch this. I need this, and then I have to do a separate one. Yeah, okay. So when you do this locally, I don't know why it worked for this one, but oh no, it worked for this one because, okay, this one's fine because this is a standalone. All right, this is where it gets a little confusing. So this actually works. So let's go back to source, and I added two matrices of the same size, whereas one was double and one was int. So let's initialize mat5 down below, and we'll print it out as well. Okay, so we do, let's let mat5 be something like, these are ints. So let's just do I plus j plus 1. Okay, and let's let matrix 3, 5, mat 6 equal that, the addition. Then we can see out mat 6. And there we go. Okay? So again, is this making sense? So once you have it in your head that templates give the compiler the ability to generate the functions they need as they need it, then you can overload all kinds of operations on objects and their underlying types. More importantly, I can add a matrix of 3, 5 doubles to 3, 5 anything else, as long as what operation is defined between doubles and that anything else. Not plus, but plus equals. Okay? So let me just go back to the template definition here to show you what happened. So let's look at matrix. Matrix, in its member, had an operator plus equals, and we had to tell it that there is a certain template pattern of this form. Okay? Now, with this one here, with the member plus equals, it needs to know the class template parameters first. And then, because the class is what's going to bring this template into existence in the first place. And then you need to include the type name F. So you do the class template parameters first. And then the local function template parameters. Okay? Because the class is in charge of saying, I need an operator plus equals of this form. And then the extra template, the type name F, comes along and says, oh, okay, then for this particular function call with the input argument is an int, so give me the operator plus equals with the int filled in for F. Okay, so it's 2 stages. This is as opposed to operator plus. Operator plus has nothing to do with any class definition anywhere. It merely states and merely says, if you need to add an object of type matrix this and matrix that, then this is what you would create. You would create a left-hand side and a right-hand side variable from those template parameters, and then you would call plus equals on the left-hand side and the right-hand side. The left-hand side tells the class definition to create an operator plus equals of this form from the class template parameters, and then the right-hand side's type, being of type f, which collapses to int, tells furthermore to create an operator, the function of type with f filled in as int. Okay, so for member variables, you have this two-level template definition. For non-member, you can just throw it all into one. Question?
Since you define the more general plus equals now, you don't need the other one, right? Because that's a more, like, it will still work, right? So you can use the f and t can be the same, but t and t cannot be different, right?
So the observation is that now that you've defined the more general operation, you can eliminate the previous code. The answer is yes. Yeah.
And then, so second question with that. So in your main function, right, you added two matrices together, right?
So in the main function, I added two matrices together. Yes.
Yeah, so one is like using ints and the other is using doubles, right? And I think the way you defined it, right, the left-hand operator,
Mm-hmm.
you said left-hand matrix, its type coerces the second type to like force it to adopt. So if the left one was an int, the resulting matrix from this operation will also be an int type, right?
No.
No?
There's no coercion going on here. The type of mat6 has to match the type of the variable mat, because the left-hand side of operator plus determines the return type. So it has to match that. You can make it match the right-hand side return type, but we've opted for the left-hand side centric view. There is no coercion. If I tried to make this a matrix of 3, 5 ints, which matches the right-hand side, this will not work because you cannot convert from matrix 3, 5 double to 3, 5 int.
So if you had an expression that was working before, but you switched, like for the top one, you have 3, 5, mat4 equals mat plus mat2. If you switch the order of mat2 plus mat, all of a sudden you get a compiler error, right?
This one here?
Yeah, if you switch the order.
Yep.
Right?
And if I switch this order, I get the same compiler error. Yeah.
Unless you specifically told matrix 3, 5 to adopt the correct type, right?
So I could overload. What I could do is I could overload a cast operator. Should we do it? Let me show you this. Well, first let me make the following observation. We could define a cast operator for matrix MNT to matrix MNF by just casting each element to an F. We can do that. That's just an operator, like casting something to operator bool or size t. Okay. Now, here's the cooler part. Do you remember the auto keyword? Now, I told you can only use it for when? Iterators. It still stands. You're not allowed to use it anything other than iterators for this class. But when you're not in this class anymore, you might consider the following. If you don't care which type it actually is, then if I write auto, then it's fine. If I write auto and I switch them, also fine. Because auto detects the return type of the left-hand side of the argument and automatically updates the code to reflect that, so you don't have to. So if you want the strongly typed nature of C++, you can get it. And if you want to start becoming a little more ambiguous about what the specific data types are, you can do that as well. Yeah?
Sorry, so now with auto, so now that the compiler figures out like what's being returned, right? And so mat6 will have a definite type. And so even though you don't see the type because you put the keyword auto, if you try calling something on mat6 that mat6 doesn't have defined, the compiler will tell you that it doesn't work, right? It's not during runtime that it fills in auto, it's during compile time that it fills in the auto.
Correct. Everything that I've done, including auto, gets filled in at compile time. There is nothing ambiguous about the auto keyword at runtime. Auto is merely a placeholder for When the compiler sees it, the compiler auto-deduces what data type it is, and it fills it in for you. There's nothing to do with runtime. There's no speed efficiency slowdown. There was no or runtime efficiency. There's no runtime slowdown. Nothing. All it is filling it in for you in a way that's more generic. One more thing before. Note, though, you might get unexpected results. Because if you add an int to a double and store the result as an int, what often happens? 5 plus 3.2 is going to get stored as a 8. So you might unexpectedly lose data by using the auto keyword. And that's when, if you don't know what's happening, you might say, well, this is a stupid library. This is a stupid program. Why would anyone code in C++ in the first place? I mean, sure, it looks nice after you do all this work, the template, and okay. But point is the auto keyword is dangerous. Okay? You only use it for iterators, for 10b, because you're not ready for the frustration that comes with trying to figure out what auto is being used in place of. Okay? If you ever were programmed in Java, I hear that can be kind of a messy point as well. But I don't program in Java, so question. Auto is really just a placeholder for, it will pick out the return type of the mat5 plus mat, and the return type is the same as the type of mat5, and it will, at the compile stage, it'll say, oh, well, according to how this function's going to get called, then mat6 needs to be of the same type as mat5, which I know what that is, so I'm going to just put it in there for you. And that way it allows you to write more generic looking code by doing mat5 plus mat or reverse, and it still compiles, but it fills in different things. Okay? Okay. Are there any other operators you'd like me to include on the fly? Oh, before I do that, just to show you, there's a reason why we spent so much time working with operator overloading and file system stuff. Look at this. File, what did I call it? Output file? What did I call the output file? Let's go to file system. The class is called read from file and write to file. Let's go to source, write to file. File write. Let's call it my matrix. Now, how would you write an entire matrix in one line of code? And this is where I can't do endl. I have to do the /n. Oh, there's. Okay. Now, what do I have to do to my file system class? Okay, watch this. Watch this. Watch this. I need to pass along a. See how I have an int and a const string? What if instead I templated that? Watch this. Friend, write to file, reference, operator, write to file, reference, write to file. And rather than picking an int or a const string reference, what if I did a t? Now, I have to write template. Now, write to file, I don't want to template that. I don't want to template that. Instead, what I want is if I invoke the less than operator, it will auto-detect what t is based on the type of obj, based on the input parameter. And then, what do I want it to do? I want it to pass along to the file stream object fout obj. And then return this. Now watch this. Oh. Oops, I need to specify. Oh, I did two things wrong now. That was really foolish. File. This is a non-member function, so I have to do file.fout, obj, and I can't return this because it's a non-member. It's for file. Okay. Ta-da! Using templates, my write to file can now accept any object of any type as long as it has what? Yeah, as long as it has operator less than defined in its own class. You're enabling your completely separate file system class to then call it. Does this file system class need to know, write to file class need to know anything about the matrix class? Not in the code itself. But when it goes to output the matrix, it will create that function as it needs it. And it's not that you need to know about the matrix class to write the code. You're just saying, telling the compiler, when you need it, you have the ability to define it. And the programmer doesn't need to put it in manually. It's the compiler that will generate it automatically. And all you're doing is locally writing those operators to locally enable the file system to locally define that function as it needs it. So basically, as long as your class is coutable, it's foutable. If we look at mymatrix.txt, my matrix. There's my matrix. Just as if it was in, cout. Now I can copy and paste these. I can read from this file as well. Similarly, okay. So how would I template the read? So we have write to file, and now we're going to do a read from file. So again, I overloaded it for string, for vector, for int. I could also overload it using templates. And then I can do, excuse me, friend read from file reference, operator greater than, read from file reference file. Now I have to do a T reference here. If I just do a T, then it's going to modify a copy and not do anything. I need a T reference obj. We need a template, type name T. And then what does it do? It just passes on the file.fin, the obj, return file. When will this operator work? That will work precisely when what? Exactly. So this will work on any class T which has the operator greater than overloaded. Okay? And again, this file is completely self-contained, doesn't have to code up any special cases. It just enables the compiler to generate special cases as you need them. This is the power of generic programming. It's only needing to specify not classes themselves, but telling the compiler how to generate classes as it needs them and being able to focus on higher level thinking rather than the lower level thinking. Okay? That is what I've been trying to emphasize for this entire quarter. I hope I succeeded. Okay, so if you take away one thing from this course, just remember that the goal of this class, not of C++ or computer science, this class, the way I'm teaching it and demanding these style choices and really emphasizing the features of C++, is to make sure that you are aware that it is not impossible to write safe code that effectively manages memory, powerful code that generalizes to as many different classes as you want, and simple, easy to read code that allows you in just a few moments to look line by line and know exactly what is happening at each line and without having to worry about the details. And then finally, this last week has been about saying, if I have templates, operator overloading, and all these tools at my disposal, how can I combine them in a way so that different people can manage and write different bits of code, but they all still magically work together and just do exactly what you would want them to do. Okay? that is the key essence here that I hope I was able to accomplish. And in 10C, we do more of that, and we do GUI programming. So you make like a game using Qt, which is exactly like C++ syntax, but just for graphics, with the graphics bent to it. Okay? So are there any questions? Yes?
Are you going to send out any information about the final?
I will not send out any information about the final. I forget which room. I think it's in this room, but I'm not positive. I'm not 100% sure on that. But it is on, you can look that up. I might mess it up. I'm going to look it up on on the CCLE. Okay? I think it's Tuesday. Yeah. But if I mess that up though, then I don't want to I don't want anyone student being like, you said it was on Tuesday and it was on Monday, or so okay. So I think it's on Tuesday. Yeah. Okay? And I may have an office hour on Monday. I will send out an email over the weekend to confirm a time if I do. Okay. Are there any other questions?
Has it hit 40 yet?
Has it hit 40 yet? I'll check it after I go back to my office. Probably it has, but even if it has, the rest of you should feel so ashamed for not contributing to this collective achievement that you immediately go and fill it out right away before 8 a.m. tomorrow morning. But if it did reach 40 or above, then yeah, I'll write out solutions and post them hopefully later today. Yeah.
What if you beat the 89%?
If you beat the 89% of the other class,
Do you write the solution in the final?
I would not. No, I would not write the solution to the final. No. It's not going to help you that much either, though. No. If you beat them, then you get bragging rights, and you're my new favorite. That's all I can really say. Question?
How long is like the final supposed to take? Is it like 2 midterms or is it more than that? Or?
It's a 3-hour final. This is a 3-hour interview, basically. If I was going to interview you, if you wanted to do an independent study with me, or if I was hiring for a programmer, I'm going to ask you the types of questions that I would want to make sure you're not wasting my time and money. Okay? That's what this is about. I don't need you to know, all the technical details of every little thing. I just need you to be an effective, fast, conceptually sound C++ programmer based on the lesson plans that I've presented for you. And I need to make sure that because, for example, again, if your code is full of memory leaks, I can't use it. I might pay you to write it, but I can't use it. If your code is not generalizable, and there's one thing wrong or I need to extend it, it's not usable. I just wasted all that time and money. That's the idea. The idea is I'm giving you an interview 3-hour exam which says, did this student understand not just how to code in C++, but to code in C++ in a way that is efficient and is not going to waste time and money. That's what you should always have in your mind, because that's ideally what a programmer does. A programmer is someone that effectively and efficiently writes code that is reusable, easily extendable, and is generalizable to be utilized in other libraries as well. Okay? Yeah, it is a full 3-hour exam. I will push you to the limit. You should come prepared to just show me what you got. Yeah. Any other questions? You get no practice for the final. I will give you no practice final exams, no anything. You're on your own. You had 2 midterms to figure out how the style works. Okay, so I'm not promising to be the exact same style, but that's kind of how I think at the moment. So it's pretty high likelihood that that's the similar style on the exam. Yeah.
Will the final emphasize more on the last part?
Oh, that's a very good question. The final does typically emphasize more on the last part of the exam, like maybe half and half. So half on the most recent stuff, and then half on the more fundamental stuff from the first 2/3 of the. So the template stuff is certainly, and then Valoré, Array, and Bitset based on the lecture material. Okay, that's going to be on there. Templates formed a large part of the later part of after the midterm. So yeah. The bonus stuff, only the stuff I covered in lecture. So Bitset, but not anything after the Bitset. So there's like this ellipsis operator, this ... on that same lecture slide. No. I didn't cover that in lecture at all, so won't be on there. Okay. And again, no binary arithmetic either. That's not on there. We didn't cover it this quarter. Next quarter, maybe, but maybe not. Okay, ladies and gentlemen, it's been a pleasure. I'll see you guys at the final.